Hello, we are Mirage Interactive and welcome to our Final 411 presentation. We are a group of passionate game developers and 3D technical artists. Our team consists of me, Colin Stearns.
Me, Joe Milton.
Hunky Kim, or Q Kim.
And Jason Bale.
Alright, first off, I'd like to thank all you for getting up at 9 in the morning and coming out to the middle of the field to hear us talk about video games. But with all that aside, I would like to talk about what my team has been working on over the past 14 weeks. We've been developing a mobile educational game using augmented reality to teach about the periodic table of elements. Now, that's a pretty big mouthful, so let's break down each part of our product and help you better understand what we're trying to get at. The first term I would like to talk about, though, above all, is augmented reality. Alright, so what is augmented reality? By definition, it's the combination of the real world that you see around us right now and overlaying some type of graphical elements on top of that. That definition is also a little confusing. So this chart here, Milgram's reality versus virtual reality continuum, will help us describe to you a little bit better what augmented reality. So on one side of the graph, we have the real environment, which is what we see right now. It's this room, it's the world, without any technical device to help us. And on the other side, we have the virtual environment, which is virtual reality in a sense. So it's a completely fabricated environment, nothing of it exists, and you need some type of technology to help you get to this environment. Augmented reality, however, is somewhere between the real environment and the virtual environment. It's right around the middle in this area over here. And it's simply using the real world that you see around us right now and those virtual assets over here and overlaying them together. You're probably wondering, though, why is augmented reality important? Well, the reason why augmented reality is important simply is because it's going to be used a lot more in the future. Augmented reality is an emerging technology that has been minimally marketed up until now. Now with the added use of phones, you can take them wherever you want to go now. So augmented reality is much more able to be used now. The most anticipated product coming up is Google Glass, as you can see in this picture here. And what Google Glass does is it uses your eye to look through a screen that you wear in your head, much like glasses, to overlay those 3D elements on top of it, so that way you can see the augmented reality and you can interact with it in your real environment. Even with all these new augmented reality related devices, you might be thinking, I know what it is now, but I don't think I've ever actually seen it used in a real world situation. But I'd have to say to you that that's probably improbable that you haven't seen it before. If you've ever seen any of the most recent technological blockbuster hits like Iron Man, you'd see that Mr. Stark is interacting with an augmented reality environment pretty much for most of the movie. In this scene, you can see him in his apartment or his house, and he's interacting with a 3D model, and he's building something around it to help, create a suit and save the world later. Now, I'm not saying that we're trying to save the world with augmented reality like Mr. Stark here. What we are trying to do is we're trying to change the world with augmented reality. In order to do that, though, we need a medium to combine augmented reality together with, and that medium that we chose is something we're very passionate about, which is video games. Alright, so video games. Let's look at this picture here from Super Mario. I'm guessing a lot of people in this room are familiar with this game. A great thing about video games is that the concepts are learned without even thinking about it. So just looking at this picture, and if you've played Mario before, you know that these brown mushrooms here with feet, they're trying to hurt you, they're bad for you. But if you play the game too, you know that red mushrooms without feet, they make you strong. So if you could take these simple assumptions that can be made about video games and use them in new concepts with augmented reality, I think that would be a pretty big thing. Making a game educational is not a new concept, however. So combining these with augmented reality to make an educational game is not something that hasn't been done before. But Oregon Trail here. This is a good representation of an educational game. This game helps its players learn about the frontier life and the hardships that people had to go through to achieve manifest destiny. This is like one of the first educational games that has ever been created and is used in schools. How is this? Now this is fun and all playing video games, but why use video games to learn? What's the benefits of using video games to learn? Go to the next one. All right. So simply put, studies have been done concerning video games' ability to teach new concepts, putting in the best answer to why video games is because they're so engaging. Many people find textbooks to be dull, but find visual allure video games in the ability to interact in ways they never did before. Technology today is rapidly expanding for video games, and in doing so, creating new educational experiences using those video games. Now I'm going to pass it up to Joe, who's going to talk about some of these technologies that we're using video games for education now.
So this is an example of a modern day educational use of a game. So this is the FIGHT program. That stands for Future Immersive Training Environment. And what this is a virtual reality simulator that reenacts a real world environment, like a real world battle situation, to train these infantry units how to react in a real world battle. This is a great example of how using virtual environments to teach. So, what is the problem? The problem is that augmented reality is still emerging technology, and there has not been enough research done on it. So, our research question is, how can we use augmented reality in an educational game to really help people to learn? So, our hypothesis is that using an augmented reality game will have an effect on the player's learning ability. So that the difference between using a standard 3D educational game versus an augmented reality educational game, there will be a difference there. So our product is for individuals who have smart devices such as smartphones, tablets, which have cameras, because as of now, augmented reality needs cameras to be able to function. So we want to find people who are looking for a more interactive and fun way to learn, or just be entertain themselves and learn something along the way. So we decided that we were going to develop an interactive game that can teach the players at the same time. And we believe that augmented reality is the tool to create that game that will be fun and educational. So, our game is called Element Night, and we are using augmented reality to create this educational game. And here you can see our main character in the game, and he is the Element Knight. So, how we tested our game was that we took students from per university, primarily from the CGT department, and we randomly divided into two groups. One group played the augmented reality version of our game, and another group played a non-augmented reality version. Now, I want to stress that these are both the same exact game, just one uses an augmented reality camera, and one uses a standard 3D camera that is set in one position. So, test subjects were given a pre-test before they played the game in order to gauge their previous knowledge of the periodic table as well as any previous experience with augmented reality. Now, after the test subjects played the game for around 5 to 10 minutes, they were then given a post-test to then measure how much they learned through the game. So again, we have our base game, Element Night, and then that is divided into two groups, the non-augmented reality version and the augmented reality version. And then for each group, they have a pre and post test. Now I'm going to hand it over to Q, and he's going to talk more about our game.
Thanks, Joe. All right. As Joe mentioned, actually, about our game, Element Night, and I'm going to briefly explain what it is. So, Element Night. It's a third-person puzzle dungeon platform, and the main objective is to escape the deadly maze by overcoming difficult obstacles or challenges. There are some key puzzle elements that derive from each element, if you see on the screen, our little two character elements. Each element has their own unique distinguishable features, such as, on the left, we have our little cute character with a light bulb. He is our tungsten character, and the stern-looking guy, who is lithium. And in the later slides, I'll briefly present the demo of our AR version and non-AR version of our game. For now, this is our first maze our group created. Our main character, Element Knight, starts in blue at the very bottom, and we made sure that the player would encounter the tungsten element early in the game. Because the tungsten is useful for the entire maze, and it'll help out our main character throughout the entire maze. In the purple, you can see, or blue, dark blue, the Element Knight has some enemies lurking around in the maze, and these are creepy shadow enemies, or something. It's a shadow enemy that lurks the ground of the maze. Upon contact, the Element Knight will lose his inventory of elements and will be placed in the beginning of the map. For the rest of the gameplay, we'll show a video of the game being played on an AR mobile phone. But before we do that, here's how we approach the educational side of our game. We decided to implement a new type of learning called tangential learning. This is a process by which people will self-educate in a topic that is exposed to them in a context that they already enjoy. So, a common example would be the Pokédex from Pokemon. Now, in the game of Pokemon, the Pokédex plays a role as an encyclopedia or library of information that isn't necessary to play the game, but the players are not forced to learn about these 150 Pokemon, 51 Pokemon inside the Pokédex, but a surprising amount of players knew and they could recite all of them. We as a group decided that this is a really interesting element to tie into our game. And with that, we decided to create a similar codex of our own. And we'll call it the Elidex, and for our game, if you look up to the board, there's an empty periodic table of elements. On the bottom, on the heads-up display, inside there's a bright green lit-up button that shows these two elements, the lithium and tungsten. If our player would touch or click on the buttons, the image of our element would show up on the right, and the text information would show up on the bottom right. And with that, the player could gain the knowledge of all these elements if they wish to. And we won't shove this information into the player's throat. We're just facilitating the learning environment of our players. Now, that'll sound really cool, Q, but how did you make it? First and foremost, the game was created in Unity. And we used an augmented reality plugin created by Qualcomm called Euphoria. Our in-game assets that involve modeling, rigging, animating, texturing, all came from Autodesk Maya. And finally, we used the Android SDK package export to build our final game product. Now, Euphoria and Unity played a huge role in creating this game. In the pamphlet handouts, on the second page, you'll see a black and white image of a tree. Now, to use augmented reality technology, the camera of your device must seek out an image that you assign in order to render out the AR game. And these images must be complex enough for the cameras to immediately pick up and say, oh, that's the image you're talking about. I should render out the game on this image. So, to put one of these image targets, Step 1, you must first upload the image, the tree in this case, to Vuforia developer website. Once we get the image approved, we download the Unity package automatically created by the Vuforia website. And 3, we will import the target image into Unity. And 4, it is ready to be used as one of our target images. Now with that, I know you're all dying to hear what our statistical analysis of our testing result is, so I'll hand it off to Jason for our next slides.
All right, thanks, Q. So as Joe mentioned earlier, our method for our test, we split up our population into 2 different groups, or 2 different populations. One to test the AR version of our game, or augmented reality version of our game, and one to test the non-augmented reality version of our game. So basically, our null hypothesis was that our augmented reality game would actually show a larger increase between the pre and post test and on the questions that they answered over the non-augmented reality game. But as we did our tests and we did our independent t-test, we found that there was not a significant difference between augmented reality and non-augmented reality. Therefore, we ended up rejecting our null hypothesis. Even though we had to reject our null hypothesis, we did find some interesting results. We were excited to see, like, we did notice there was a change between the pre and post test. As it shows here, there was an average increase of 13% in the AR version and 18% in the non-AR version. Although that's not as high as we wanted it to be, it did show that players actually learned something as they were playing the game. So players came out of the game with some new knowledge. The graphs on the left there, or on your guys' right, sorry. These graphs actually, they show the amount of, the number of questions that our participants got right. How many each participant got right, or up there. So that actually shows the red is the pre-test and the green is the post-test for each augmented reality and non-augmented reality. And what we saw is that even though there wasn't a drastic change, it wasn't statistically significant, we saw that there was a slight change in what people learned. We also found that augmented reality actually, people ended up saying that they enjoyed that more, or more people on the augmented reality test said they enjoyed it a lot as opposed to the non-augmented reality. If you look at these 2 pie graphs, or pie charts, they actually look pretty similar, but the main thing that stood out to us was that on the augmented reality, 25% of our participants actually said they really enjoyed the game. And then we contrast that to on the non-augmented reality, a little over 20% said that they really did not enjoy the game on the non-augmented reality. So we thought that was an interesting thing that there were the 2 extremes on these 2 games. So after we did all our testing, and we went ahead and started looking at what the feedback we got from our participants. And we did encounter a few problems that could have affected how our results turned out. The biggest problem that we had is that we did not have enough content. And this ended up being because of time constraints. We ended up running out of time. We had hoped to include 6 to 8 elements with about 3 levels for the player to traverse through. What ended up happening is to get the game to run, we weren't able to implement as much as we wanted to. We had several elements, such as this one, which was going to be a model of helium. That was something that could allow the player to float over obstacles because of its light characteristics. But we ran out of time and weren't able to implement that. Another problem that we had is a lot of players didn't seem to understand our UI, or inventory system. So we did have a problem with that. It wasn't as intuitive as we intended it to be, and that leads into there was not enough instruction in our game. We did not put in enough. We found that players were constantly having problems understanding what the game wanted them to do next, and we found that we should have put in a few more hints or designed the game a little bit differently so that the player could understand what they needed to do. And some of the other things from the comments that we got, if we need to go back and change, were that the text was too small to read. The way that it showed up on the screen, it actually didn't show up long enough, and it was too small to read. The AR controls were too difficult to understand for some people. Most people are not used to playing an augmented reality game on a mobile phone where you actually control the camera in a 3D space while you're controlling the character running around. So that was that was kind of difficult for people to adapt to if they had played other types of games normally on a phone. And this goes into the way that you play it was somewhat difficult for some players to hold because they're used to just putting their hands behind the tablet or the phone and just holding it comfortably. But when you do that, a lot of times people would cover up the camera lens, and that would pause the game from what the settings that we had, and that would kind of break the player out of what they were doing and kind of disrupt their game. And lastly, all of these things came together to a lot of people saying that it was a little too difficult to complete. So I'm going to go into our legacy. We did have some problems, but we think that a legacy group could definitely pick this up and expand on a lot of things that we did. The first thing, as I had said before, that we had seen as a problem was that our game content was not enough. From a lot of the research we saw, you really need to get players engaged and really involved in a game for the tangential learning aspect or any learning aspect to take effect. We found that our game was not long enough and there weren't enough elements to really get the player involved in the game. So a legacy project could be adding more levels to the game and definitely increasing the amount of elements so that there's a uniqueness, maybe a little bit different challenge that players would have to go through. Another thing that could go into legacy is that the game issues that we had, specifically the user interface. There's different aspects of that to make it more intuitive for the player, make it easier to navigate through, easier to equip items. And along with this user interface, we could work on the Elidex to make it a better tool for players to use, and they feel more inclined to actually search through it and learn a little bit on their own, as well as add more instructions to the game and make it so that players aren't confused and that it kind of flows naturally as they go through the game. And lastly, one of the cool things we were thinking about is that all of the new technologies that are coming out that could be used with augmented reality. As Colin mentioned earlier, there is the Google Glass, which is coming out in 2014, or is a release date in 2014, that is going to be based on augmented reality. And there is the possibility that our game could be adapted into a new device such as that. It would get rid of some of the limitations we had, such as the player having not being able to interact with the augmented reality item in front of them. They had to hold the device, but with the Google Glass, you would be able to just have the glasses on, and you could maybe put some more user input functions in. And then also, as more and more research is done into augmented reality, they're attempting to move away from these target images that you need to have. Because right now we're limited to, you must have the target image to play any of our games, or to use these devices. And so we're kind of limited where if you don't have that target, you can't play the game. Your player can't just pick up this game and play it in class without having something sit in front of them. So technology is moving towards giving us the ability to recognize just flat surfaces or place games or interact with different objects in your environment, such as items on a desk or a table. So there, as you can see, there's like a lot of different ways this project could go, and there's a lot of exciting and new opportunities that could be taken.
So we're going to show you a little demo of our game here.
So you can see the player is picked up an item and equipped it. Whenever you look away from the target, you would actually equip an item. You could move around the target and you can run around. Actually, the item they equipped was tungsten, which allows the player to defeat the shadow enemies that he encounters by casting a light. Now the player can run around and he interacts with another element. This element's lithium, which can allow him to get farther into the level. Also, as the control on the side to move, there's a joystick that wherever you press on the left side of the screen, it will build a joystick there and allow the player to kind of choose where they want to put their finger so that they're not always blocking their character. So yeah. So as you progress through the level, you kind of encounter more enemies. You have to get through these doors by activating the generators using lithium, which is kind of our power source. Right there, picking up another lithium. See, the lithium, the other elements are kind of just patrolling around the level. Alright. And he's opened the final boss door, or the final door, so let's see where it goes.
How you beat the boss is you absorb the boss's attack with lithium and then you shoot back at him.
It takes a few hits. And before we open it up for questions, just wanted to thank everyone for coming. I know it's early, like Colin said, we're out in the middle of nowhere, but we really appreciate everybody coming out here. We also want to thank our sponsor Carlos, who wasn't able to be here today, but he helped us out a lot, and he gave us access to a 346 lab that we spent a lot of late nights working in. We also wanted to thank Professor Burton for giving us this opportunity to work on this. So if you guys have any questions, shoot.
I know you mentioned you were using it on Android, but did you ever consider implementing your game on the iOS?
Good question. Yes, we've tried multiple ways to get our game onto iOS. However, while we were building our final version of the game, there were Apple standards that our games didn't meet. And we, as developers, could figure out how the game, how we could port this to Apple. We tried multiple ways, but all of them failed. So unfortunately, there is no Apple build as of current, but maybe in the future legacy projects, people might figure out how to do this.
The main problem was that we have, our game is primarily in C#, but we also have some JavaScript code in there, and Apple standards require all your programming to be in one language, or it to be set in a particular way, which we were not able to do.
Yeah, I'd actually like to add on to that. For iOS, once you actually have it built out too, not only do you have to get it approved, but you have to be pre-approved to even get it to there by getting a Apple developer license. So we didn't even get the Apple developer license. We were trying to get through loopholes to get that too. So if we would have gotten that, and then we would have done all the other stuff too, we might have been able to get it working for iOS.
Any other questions?
So your conclusion was that augmented reality didn't really help with people learning? Is that what the...
That's what our test showed, and so that's what we had to. Our test showed that there really was no significant difference between the two different game types that we made, and just That's how we understood it, is that from what our type of game, the way we did it, which it could have some other variables, as I mentioned, some of the problems could have affected it, such as the way we actually developed our game actually doesn't work with augmented reality, or the way, or some of the issues that we had may have caused that result.
Because just noticing that you were recommending this be a legacy project, so it seems like you guys still believe in it, but maybe if it was executed differently.
Yeah, I think that's what we had started thinking, is that we found kind of overwhelmed with this project at some points, and that's why a lot of things ended up, we had to kind of get things done, and there were things we had to take out of the game that we thought were going to be really great. We had a lot of great concepts for it. But as a legacy project, if somebody took this up and was able to fully flesh out the game and fix some of the things that we had problems with, then I really think that, or I think we as a group think that it could be something where we would actually start to see a change between the two different technologies.
Who's your content expert on the periodic table and educational methods and all that kind of stuff?
I think-
Who mentored you to say that there would be a linkage between what you were doing and really learning the periodic table?
We mostly did research to learn about, we did research into, like, we looked at other people's studies about what they found from doing educational games. So we took what we learned from them about tangential learning and building all that stuff together, and we just tried to apply it to the periodic table elements to see if we could do it the way they did it before. We didn't actually have an expert in like chemistry or anything.
Yeah, well, see, that's what I was trying to understand. I don't think this project is about education. I think this project is about you guys trying to discover how to make an IR game. And so the education side is pretty irrelevant. So about 300 questions I have here are really irrelevant, because there appears to be little to no relationship. You made some things run around and you shot and picked up things. And I didn't even see standard periodic table symbols. So I don't know how to correlate knowledge of that table with those elements. And so when you talk about being overwhelmed, it's obvious. You bit off an awful lot. And I think we had that conversation earlier, that it was going to be very difficult. I wanted you to show your game earlier because I really wanted to understand it more. Why is it that view? Why is it operate that way? What kind of user interface things did you discover, to make those decisions? Why is the button here? Why is it a maze? All those things. Do you have any comments on the game itself? How you arrived at those?
As for the game itself, we chose a third-person perspective of a puzzle maze game because we wanted to fully utilize our AR technology, and because for AR games, we as a player could freely control the camera of the game in the game world. As a different third-person, let's say another third-person puzzle maze game, the camera is inside the game world, but is constrained to the players. So all they would be seeing would be the players and the walls that are behind them or in front.
Sure.
And if we use AR technology, the players could freely look around the map. So the reason we did the maze was, you've seen some of the open borders that you could have seen. I thought it would be really neat and unique concept that if you were to use the AR technology, you could fly around the map and see what kind of enemies that lies in front of the next room or a different room. But again, there's some constraints such as the ceiling of the maze that was inside the demo of the game. But yes.
And is it typical to do a 3D environment like that where you see everything about the maze? There's no, oops, that's a blind end, I don't want to go in there.
Yeah, that's why we added in. That's why we added in kind of like as you open a door, it would unlock a new area. We did originally had talked about implementing a fog to the game, whereas the player explores, they actually see more, and so that explores more. But like as we were building the game, we had difficulty trying to get that to work, and we ended up just having to settle with blocking off larger sections, as opposed to as the player explores, more sections are viewable.
So would you say that your decisions were being managed by the technology?
Yeah.
more than doing what you wanted to do?
No, we decided this in the beginning that this would be a very unique concept to tackle because of the freeness in the camera that we have. It's just that we want to constrain all of the freedom that the player has in order to create much more exciting gameplay.
See, that's a hypothesis, right? That probably should have been the one you tested instead of this other one. By the way, null hypothesis means no difference. All right, so it's the other way out. You got it backwards. The assumption was you were doing this because there is a difference, right?
Yeah.
You didn't do this because you didn't think there wouldn't be a difference.
That's true.
Typically,
Yeah.
the treatment, you know, okay, all right, let's check. How many people did you test?
We ended up testing
45.
45.
And if you can summarize, you know, you've got that comment section where you have very conflicting data. You know, they really enjoyed it and they really didn't like it. What do you think the contributing variables were to those comments? What were the major things to the 26% or whatever it was that said they didn't like AR?
One of the things is some of the people actually wrote in the comment section that they just don't like mobile gaming at all.
Oh,
They like
okay.
gaming, but they just don't like doing it on a mobile phone. So that some people just might have been swayed by that, just the fact that we had it on a mobile device and they don't want to game on
Well,
it.
that's really interesting. What do you think? In the literature or what you know has contributed to that? I mean, is that an evolutionary thing?
From what we've discovered in the literature, I mean, a lot of the stuff pointed to mobile gaming is kind of like the way that everybody's moving now. Is that being able to carry a device with you and play all the time is kind of, and then the fact that it's now these games can be played on your cell phone as well. That's becoming more like your computer. It's like everything is with you at one point. It's kind of like a lot of
So the
people-
literature's saying that this is progressive evolution, but yet your data is saying that a quarter of these people
Don't even like mobile.
don't like mobile
Yeah, I
gaming.
think what it is that most of the people who say they don't like it, they're just used to the old way of doing things. They don't really want to.
So it is evolutionary. In other words,
Yeah.
as people evolve.
More people, as it goes on, I'll see more people actually liking it.
So what's your guys' experience?
Besides the people not enjoying the mobile aspect of the game, I believe that although it was a mobile game, we didn't fully grasp the mobility of our game since the players require the target image for the AR. And it's kind of difficult to carry around places to places in order to play the game. So I also believe that was an issue with the players disliking the game because they weren't playing a mobile game, but they were supposed to be constrained to a certain location. So
Yeah, I was kind of confused about the AR part of it too, how that played into that game. So you shoot the little tree and you get the game on your app, right? So,
It's like in real time, the phone or your smart device. If you look through the screen, the 3D target or the 3D scene will appear on the desk or whatever.
yeah, that's what I thought it was
Yeah.
supposed to be.
And if you look away, then target, it disappears and stuff, so it's always going to
So,
be a bit.
so the example you showed though was of someone holding the device, see?
Yeah, you have to,
Yes.
by looking through the iPhone, or whatever smartphone,
Android.
the Android, we did use an Android. Looking through the Android, you would see the game out on the table, but I mean, when you didn't, it
But you
wasn't,
could video that, that's right.
well,
yes.
yeah,
Right,
we did,
We wanted to demo it in here and actually have it go
so
to the
you can
phone.
see it.
Yeah, but the problem was, they don't have a technology right now that can, in real time, show whatever the phone is seeing onto a
Right.
computer. Like, I got something working for it, where you can actually pull the phone up and you can see what's going on, but it shows you like a frame every, like, 2 seconds. So it would be just not beneficial to show you guys
So it was
that.
difficult to demonstrate.
Yeah, it's very hard.
we did want to demonstrate it through our development lab. Well, we wanted to demonstrate our game, not necessarily the augmented reality portion, but we were unable to hook it up to the projector here.
So if you would give advice to somebody that wanted to do this in the legacy, I'm sure somebody will, probably not your game, but they want to do their own game, because that seems to be the product emphasis of this. What's the one major piece of advice you would tell them very beginning of the semester so they don't experience this large amount of decision-making with little mentoring that you had to go through?
For me, I would say the biggest key factor would be the scope. Like any other game projects, make sure you have your scope down as just look at your team's abilities and figure out where your limitation is. And if I were to say another thing, would be to figure out a good way, a better way than how we did, use augmented reality on a mobile device to play games. I think it would be interesting if they were to implement a much more mobile version of a game that uses augmented reality, such as using everyday life images that could be a real tree that could be standing out there, and you could play a simple game, let's say cut down a tree game, that you could play.
See, one of the things I'm wrestling with is the scope obviously got way out of hand, but you guys, one of the goals, of course, is that you have to have something that you leave here with that leverages your position in the real world, right? I'm trying to make that link about what you did and what knowledge you gained that you could use. And so in other words, what is the worth of the project? And if you advise someone in the future about where to focus, how does that fit within the breadth of what you're trying to be as a professional? So are you guys, you're wanting to go in the gaming industry, right?
Yes.
So what about this project has leveraged your position?
Well, working on this project, I know a lot of us learned a lot of stuff about Unity, how to program in that, learned about game development in general. I did a lot of the assets or the 3D modeling, so I got to model for a mobile game, which there's a lot of jobs out there now where they're looking for people to model for that, and there's different things that you have to consider when modeling for a game, such as lower poly count and not getting to just the limitations for that device. And so there's a lot of, I feel like we learned a lot about how to create a game.
Okay.
And then we also experienced something with this Euphoria, which we may have not implemented the best way that it could possibly be implemented, but to take that to a company and say, we know we've worked with an augmented reality thing, and it's a lot of the applications could be in marketing or something.
Also using the Mirage SDK to build out games from Unity and export it onto like an Android device.
Yeah, so for you personally, the future of this product is what? I mean, in other words, you go to an interview, you tell them all this, but you can't show it. Or you can show it.
Oh, yes,
We
could.
We could show them it.
Okay.
Pull out the phone.
It is demonstratable. You would need an image target and an Android device, or there's always like a video that could be shown.
Well, I don't think the video is really effective.
Yeah, the video isn't as effective as actually seeing it. I think one thing that would be great to be able to do is to somehow get the problem that we had that was making it so we couldn't put it onto the iOS, because majority of the market right now is iOS. So when you say, I want to show you this, it's kind of hard when you constrain it to Android, because not everyone can actually view it, which is a problem we ran into.
How many devices did you test on? Because I've got 2 Android devices here and it's not running well on either of them. It's not syncing to the target, it's throwing the map off to one side of the screen, it keeps throwing the periodic table up while I'm trying to play.
How close are you to the target? You have to go back a little bit farther. Yeah, no, you might want to go back
Okay,
farther than
and-
that too.
Just like go back to what Terry was asking, what's AR bringing to this other than forcing me to point my phone at the table? I can go on the Android store and I can get a ton of apps where I can spin my phone around in this room and I can have TIE fighters coming out of the corners at me and I can shoot them down. There are Foursquare versions of things where I can walk around town and actually see the tags on buildings. And so the world is integrated into the app. Here, I'm being forced to hold my phone here while I play a game. I hold my phone here while I play a game anyways, even if it's not AR. So what's the benefit?
What we had originally intended is that we wanted the user to actually use the target and look at it from different angles. And as we had wanted as a maze kind of element, we had talked about maybe there would be some components where you actually had to look at the maze from a different angle to get by or do something. That was something we didn't end up getting into the game. So yeah, it really didn't end up being a huge part. We couldn't show off why the augmented reality was working as well. It was more of, like, does it just seeing the game in a different perspective is when you see it, it's like, okay, it's on the table. Does that have any? That's really the thing that we were showing right now. I mean, we wanted to implement some more aspects that actually utilized being able to move around the character that way, but we ended up not being able to get to that. Yeah, so that's kind of the thing, and we were just kind of constrained with the technology that we used, that we ended up using. It constrained you to this image target, whereas there is that TIE Fighter game where it doesn't have a target, it just kind of has the things fly at you, and that kind of doesn't use any targets. You could look at the ground and the things would come from the ground. And so it was kind of a little bit different than that, and it's just our technology that we used.
Thanks for coming out, guys.
Okay, thank you guys.